Hey, 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 hey. Welcome back. Unit 3, Lesson 9, Part 2. I hope I didn't scare you off there with Part 1, but I just like simplifying trig and doing the whole 9 yards. And I don't know. Let's just dive right in and pick up where we left off, shall we? Now, first off, this is where we left off here. Uh, trigonometric identities. Okay, here are some guidelines. Okay, but before we get into this, I would just like to point out we finished these problems using the Pythagorean identity. All right, and if you remember from the where did that little thing go? Okay, yeah, it's still recording. That's fine. Where we left off here, Pythagorean identity. In the beginning here, bang, right there. Here's our Pythagorean identity. But there were these two other equations, okay, rules, so to speak, and they are also listed underneath the Pythagorean identity. And I want to take 2 or 3 minutes to point these out. They may or may not come into play, but if they do, I just want you to kind of, in the back of your mind, be introduced, I guess, to them and somewhat familiar with them. Okay, so first off, I'm going to take a look here, and we know that sine squared plus cosine squared is 1. We proved it last video for lesson 9, part 1. All right, and these other two identities here, they really are different forms of this one right here. Okay, and let me explain that. Okay, first of all, whenever we have equations, okay, we're solving for an x. Whatever math I do to one side, I have to do to the opposite side of the equation to keep it balanced, right? So what I'm about to write in blue here, I just want you to pay attention. It doesn't have anything to do with this tangent and this trig stuff here, secant, whatever, yet, but it's the same basic rule, and we already know it, okay? I just want to bring that to the forefront of your brain. If I have 6 times 3, okay, that's a 3, plus 2, that's 18 plus 2, we should get 20, right? So let's say we didn't know what 3 was. 6x plus 2 equals 20. I solve this, x should end up being 3, obviously. But I can, using opposite math, okay, I can keep the equation balanced. So first of all, I can subtract 2 from both sides. That's opposite math, right? I'd get 6x equals 18. I still divide by 6, and I still get my 3, correct? But what we are going to do algebraically to get from this equation to these two equations is what I'm about to show you right now. All right? So again, I mean, just keep watching. If I have 6x plus 2 equals 20, I can say, well, I know I can divide everything by 2, and my equation should still hold true. So now I have 3x, because 2 goes into 6 3 times. 2 divided by 2 is 1, equals 2 goes into 20 10 times. If I were to solve this, okay, subtract 1, and I get 3x equals 9. And if I divide by 3, my x still equals 3. I'm still good. My equation still held true. So what I'm basically saying is, this step right here where I divided everything 2, and I ended up with this right here, that's the same thing as what I had before I divided by 2. 6x plus 2 equals 20. It still holds true. It's still a true equation or mathematical statement, and my answer did not change. It's still 3. Okay, so if I divide the left side by 2, I had to divide the right side by 2. Okay? That's kind of what we're going to use. And by saying kind of, that is what we're going to use. And I want to use an S for sine and a C for cosine. Okay? If I take sine squared plus cosine squared and set it equal to 1, okay? Let's say I want to divide everything by cosine squared. Okay? Just like here, I divided everything by 2, right? Okay? And it stay the same. I'm going to divide this by cosine squared, divide this by cosine squared, divide this by cosine squared. What I end up with is sine over cosine, that's tangent. All right? If my sine and cosine are both squared, this tangent should be squared, all right? Plus cosine squared divided by cosine squared is 1 equals 1 divided by cosine is secant. If my cosine is squared, if my trig here is squared, my trig here should be squared. And that's exactly what we get here. So this middle equation, this middle Pythagorean theorem, the tangent squared plus 1 equals secant squared, it does come from sine squared plus cosine squared equals 1. So that's why it works. So if you ever see tangent squared plus 1 anywhere, you can substitute secant squared right into it. Now let's do the same thing for this last one. Right? I'm still going to have sine squared plus cosine squared equals 1. But instead of dividing everything by cosine squared, I'm going to divide everything by sine squared. Again, if I divide everything on both sides of the equation by the same value, what my result will still hold true. Anything divided by itself, 1, plus cosine divided by sine. That's the flip of tangent, isn't it? The reciprocal of tangent, which is cotangent. And if these trigs are squared, this one should also be squared. Equals 1 over sine. The inverse of sine, or the reciprocal, I should say, of sine, is cosecant. If this trig is squared, this trig should be squared. This is the same thing as this. Mister, it's not written the same because in addition, order does not matter. Okay, I could say cotangent squared plus 1 equals cosecant squared. And there you go. It's the same exact thing. And I just wanted to explain these because I didn't explain these last video, but I wanted to explain them now. And now you know. Okay, but ultimately they come from sine squared plus cosine squared equals 1. They're just variations of them. All right. Okay, now that that's out of the way, let's go back to our trigonometric identities, and let's do these things here. And there's some guidelines here, and people do things. Some people do things different ways or whatever. I just convert everything to sines and cosines, and I think that's the best way to do it. And these instructions here, I believe, reinforce that. Okay, so step 1, work with one side at a time. Don't try and work with both sides simultaneously, because you don't always have to change one side. Okay, so work with one side at a time. Okay. 2, and this is a big thing. Okay, this is the very, very, very big thing. Very big thing. Okay, convert. Okay, yeah, I should do that. Convert all terms to sines and cosines. That is a golden rule for anything whenever we're working with trig identities and simplifying trig expressions or equations. Okay, and then look for opportunities to factor or to add fractions or whatever. We'll get there. Okay, we'll get there. So let's take a look at this first one. Okay, sine of x times cotangent of x equals cosine of x. So in my mind, if I want to change everything to sine and cosine, this is already sine over 1. Cotangent is cosine over sine. Okay, I'm changing this to sine cosine. Now this is already cosine, so I'm going to leave that cosine, which is cosine over 1, isn't it? So I'm going to work with the left side because the right side is always sine and cosine. This is already in that form, but plus I just want to kind of manipulate one side at a time to make it easy for myself. Right? If I look at the left side, my sines cancel, and I get cosine over 1, which ultimately is cosine. And that equals cosine. Check, it's good. These have x's in them, so please make sure you put your x's here. There are x's here. I know I don't write them during the process, but you should put them back in for your answer. There you go. All right, let's look at this next one here. Example 2. Nothing is in sine or cosine form. But you know what? This is going to equal cotangent. So I'm going to leave the right side alone. I'm going to try and get the left side to equal cotangent. Cotangent is ultimately, in my mind, you should be thinking, cotangent is cosine over sine. So ultimately, if I can get the left side to equal cosine over sine, then it equals cotangent. All right? So let's start manipulating this. I have a fraction here. And in this fraction, I'm going to take the numerator and turn it into its own fraction, and the denominator and turn that into its own fraction. What do I mean? Well, I'm glad you asked, because I just so happen to be a math teacher. Sorry, dad joke. Couldn't resist. Cosecant. That is 1 over sine. Okay, when you use the S for sine. Secant is 1 over cosine. All right? Now, I have one fraction divided by another fraction, okay? I want to get rid of the fraction over the fraction and just get one expression without a fraction if I could, or at least one fraction without fractions in it, okay? So I want to get rid of this numerator. I don't want a fraction in the numerator, so I multiply by the reciprocal, cosine over 1. They cancel, boom, boom. What I do to the bottom, I have to do to the top. All right, so now let's do this. 1 times cosine is cosine, over 1 times sine is sine. Oh my God, cosine over sine is cotangent. We'll use an x. Okay, equals cotangent of x. So if I want, okay, I can now say cotangent of x equals cotangent of x. I want them to be identical. I don't want it to be interpreted. I want it to be identical. And cotangent equals cotangent. Gadoosh. It's good. We're nice children. Number 3. All right. Now this is where things step up algebraically. Okay. Now with sines and cosines, they don't get any more complicated than they already are. They're going to remain the same. They always do. It's the algebra that changes. Meaning, for number 3, okay, for number 3, I'm going to take this one fraction and break it up into 2 fractions. Okay. So I'm going to say the sine over cosine minus 1 over cosine, okay? Because I can break this up into 2 fractions. If I were to combine these, like if I had to solve these, when I subtract fractions, doesn't the denominator stay the same? And I have sine minus 1, so that's what I get, and that's what I have here. All I'm doing is breaking them back apart. I'm taking this and breaking them back apart into the 2 fractions that we're subtracting, okay? That is a basic algebraic move. Now, it equals tan of A minus secant of A. All right, well, let's take a look at this. Oh, man, this is beautiful. Sine over cosine is tangent. Okay, and minus 1 over cosine, that is secant. And we're using A. Okay, tan of A, secant of A equals tan of A minus secant of A. Wow, that was a lot easier than I thought it would be. It's nice. The big thing is this needs to be broken up into 2 fractions that you're subtracting instead of 1 fraction where you have the subtraction in the numerator. Okay? So let's take a look at example 4. Oh, example 4. Ugh. All right. I have cotangent squared of x equals cosecant of x minus 1 times cosecant of x plus 1. Now, my brain is trained to see this. I am not going to mess with the left side at all. That is already one term. It's nice. It's easy. It's simple. The right side, I've got to try and do things. Now, I said the algebra is going to step up. The trig stays the same. The reciprocal functions are the same. Tangent is still sine over cosine. Secant is still 1 over cosine, just like in example 3. That never changes. It's the algebra that changes. Like for example 3, the step up in algebra was taking the fraction and breaking it up into 2 fractions. Okay. The algebra for 4 is I'm actually going to FOIL the right side. Cosecant times cosecant is cosecant squared. Cosecant times 1, well, that's plus 1 cosecant. Negative 1 times cosecant is minus 1 cosecant. And negative 1 times positive 1 is minus 1. All right? So, these cancel. And I end up with cosecant squared minus 1. Okay? Here we go. And we're going to continue this. And you might notice, okay, this is equal to, in case you didn't know, this is still equal to cotangent squared. Cotangent squared. You might be like, oh, the cotangent, cosecant, the one, that's, oh my goodness gracious. That was here, wasn't it, Visca? Isn't it this? This is cotangent squared plus 1 equals cosecant squared, okay? Cotangent squared plus 1. Huh. So let's go back. Our equation was cotangent squared plus 1 equals cosecant squared. So what can I do? It's not the same. I got cosecant minus 1. Oh. So what can I do? Why don't I just add 1 to both sides? So I've got cotangent squared plus 1 equals cosecant squared. And this, based on our equation, one of our Pythagorean identities, a version of it, is cosecant squared. They are using an x equals cosecant squared of x. Very, very, very good. Now, if you wanted to, I could have. You know, I have the cotangent squared here. I said, well, I'd like it to equal cotangent squared because that's what they give us. Well, let's take a look at this. One of our Pythagorean identities is cotangent squared plus 1. If I subtract 1, that also tells me cotangent squared equals cosecant squared minus 1. Okay? I can do that, and here's cosecant squared minus 1. That is cotangent squared. So I could, if I wanted to, I could do it that way as well. Okay? They're both correct answers. You just need to prove that these are true, and this proves that it's true because you got both sides equal to each other. So it's true. Did I mention it's true? Because it's true. I'm going to have some coffee and pause this. And then it's true that I have coffee. And that's the truth. It's true. Now that I've said the word true 15 million times, let's take a look at example number 5. All right? Let's take a look at example number 5. Cotangent times 1 minus sine equals cotangent minus cosine. All right? Well, the parentheses on the left-hand side, I want to get rid of that. So I'm going to just distribute everything, okay? I'm going to distribute everything. Cotangent times 1 is cotangent minus cotangent times sine, okay? That equals cotangent minus cosine. Well, look, we got this here, so chances are this is going to turn into cosine. And that's what we're hoping. So now, all right, if I want to, and changing everything to sine and cosine, you know, it still helps. And I could have done that with any of these other problems, okay? And let's do this. This is cosine over sine minus cosine over sine for cotangent times sine over 1, that's sine, equals cotangent. Let's make it cosine over sine minus cosine over 1, okay? This is what it looks like in sine and cosine form. I know I haven't been doing this because we end up converting it back, but I'll do this one with all the conversions. The only thing I can do at this point is right here. My sines cancel, and I end up with cosine over sine minus cosine over 1 equals cosine over sine. This doesn't change, minus cosine over 1. They are exactly the same right now. So I can put those all in cosine of x, right? There are x's here. I go with cosine of x over sine of x, whatever. Or I can just convert these back. This is cotangent of x minus cosine of x equals cotangent of x minus cosine of x. Done and done, man. The dishes are done, man. It's good. God saw what he made, and he said, dude, it's good. It's good. We're good. We're smart. I say that all the time. You want to know why? Because it's true. It's a beautiful day in the neighborhood. Won't you do math? You should do math. Okay, we're done. Let's go on to the next one. oh, word problems. Okay, using trigonometric identities to find the trig. I'm just going to say trig. I don't, trig values. How about that? Okay. Given that sine squared plus cosine squared equals 1, and sine of theta equals negative radical 3 over 2, what is the value of cosine of theta? First thing I notice, you see how it says theta here? Then it should say theta here. Okay? If it says theta here, it should say theta in, okay? Or if it says x here, then it should say x here. If it says x here, it should say x here. So just know that they represent the same thing, okay? They represent the same thing, okay? So let's get rid of this. I'm going to start by saying sine squared plus cosine squared equals 1, all right? So they're telling me sine is negative radical 3 over 2. So I'm literally going to substitute that in for sine. Negative radical 3 over 2. I have to square it plus cosine squared equals 1. And now it just becomes solve for the variable, c. Now, if this was written out, this would say cosine, right? This would say cosine. And people freak out. How do I solve for cosine? That's still that's the unknown you're solving for. Cosine would be like your variable. That's why I changed it to c, so it looks more like a variable instead of trig. And people feel cozy and comfortable with it that way, okay? So let's square our fraction. Keep in mind that if I square a fraction, that's like squaring the top and squaring the bottom. Negative radical 3 times negative radical 3 is 3 over 2 squared, which is 4, plus c squared equals 1. All right? Basic algebra. I'm going to subtract 3/4 from both sides. Oh my goodness, people. C squared equals. If I have $1 and I take away, this is 75%, 75 cents, because that's 3/4, and I have 1/4 left. Okay? I'm proud of you for knowing that. And if you didn't know that, but you admit you didn't know that, that's still big on your part. That's still big. You should admit. Okay? It's the first step in recovery. Okay? The first step in being good at math is admitting that, you know what, maybe I'm not so good at math, but I want to be good at math. So let's be good at math. And let's continue this problem. Okay? I don't want to solve for c squared. It's not asking me what c squared is. It's just asking me what cosine is, not cosine squared. So I need to solve for c. So I'm going to take the square root of this, and I take the square root of this. So c equals, taking the square root of a fraction is like squaring a fraction. You need to do that to the top and bottom. So I have the square root of 1 over the square root of 4, which equals 1/2. That's the cosine of theta. Remember, whatever they're asking for the cosine of theta. So you tell them what the cosine of theta is. Boom, 1/2. Own them like a boss. And if you just told me there, Visca, what about, I thought when we take the square roots, it's what? Don't forget, when we get rid of a square by taking the square roots, plus or minus. It's always plus or minus. Because we can have an angle that does, of a cosine that does equal negative 1/2. And we could definitely have an angle that equals positive 1/2, all right? Last but not least, yep, that's the last one. I'm sad. I'm sad because it's almost over. But anyways, all right. Given that sine squared plus cosine squared equals 1 and cosine equals radical 2 over 2, what is the value of tangent? Oh, if you know your angles and special triangles, you could probably answer this. Is it 1? It might be 1. I don't know. Maybe I'm wrong. But maybe I'm right. Okay? And if I am right, I'll explain how I knew that before we even did this. All right, so we're going to do the same thing. We are going to solve for sine here. How do I know that? I need tangent. Tangent is sine over cosine. They give me cosine. So in order to find tangent, I need sine. How do I find sine? I take my cosine value and plug it in for cosine. It's the same thing we just did. We're just taking it one minor step further. So sine squared plus cosine squared equals 1. Cosine is radical 2 over 2. So I say sine squared plus radical 2 over 2 squared equals 1. So sine squared plus, don't forget, I need to square the top and the bottom. That's 2 over 4 equals 1. Okay. So now I got sine squared. This is the same thing as a half. Okay, 2/4 is a half. If I subtract a half from both sides, sine squared would now equal 1 minus a half is a half. Now I got to take the square root of both sides. Oh my God. Becky, look at her. All right, here we go. So it's the square root of 1 over the square root of 2. And that is 1 over radical 2. But if we want to simplify it, if we want it in simplest form, I don't want a radical in the bottom. So I'm going to multiply my bottom by radical 2 and my top by radical 2. So I end up getting radical 2 over 2. All right. And let us not forget, anytime that we take the square root to get rid of a square, it's plus or minus, okay? So I now have sine, okay? Here's sine, here's cosine. I can now figure out tangent. If tangent equals sine over cosine, sine is radical 2 over 2. Cosine is radical 2 over 2. What is anything divided by itself? And they give us theta here. It's 1, like Mr. Visca said. But keep in mind, we had a plus or minus here, right? So we should have a plus or minus here, which means it could be positive or negative 1. All right? And that's the answer. So Visca said he thought it was 1. He thought it was 1. Okay? Let me explain to you how I knew that. Okay? Cosine they gave us was radical 2 over 2. I knew, because I've done this a million times, ultimately it was 1 over radical 2. We just happened to multiply the top and bottom by radical 2 to get this. I knew this. And right away, those numbers screamed to me, what special triangle has a 1 and a radical 2 in it? A 45, 45, 90. The sides are 1, 1, radical 2. Okay? So if the cosine of 45, right, is adjacent over hypotenuse, that's 1 over radical 2. So that means this is 45 degrees, the cosine of 45 degrees. So what's the tangent of that same angle? That's what they're asking us. Tangent is opposite over adjacent. This is the hypotenuse. It is 1 over 1, which is 1. Okay, so I just figured out the tangent of 45 using my special triangle. I knew this had to be. This angle had to be 45 degrees because I had to have 1 over radical 2 to get this. That came from 45 degrees. So if my angle here, theta is 45, well, what's the tan of 45? Opposite over adjacent. And of course, for our sake, though, it was plus or minus 1, okay? So that's it. Man, I think we just got a review for a test, and then we got a test coming up. I don't normally put unit test reviews online. I'm debating. I might do that here. It's a good summary. It's good for the kids to look at it. I might do that. I didn't do that for Unit 1 or Unit 2. I might do that for Unit 3 because, hey, the good students are going to look at it, and they're only going to get better. And the students who don't care, that won't look at it, well, they won't look at it if I put it up anyways. So I guess really I'd just be holding the good students back by not putting it up. I just don't like to do every single thing. Okay, that's my conundrum. That's my counter argument. That's my devil's advocate. Orange devil. So, I don't know. Maybe I'll see you for Unit 3 test review. Or maybe I'll just see you for the beginning of Unit 4, Lesson 1. Either way, I'm definitely going to miss you until we speak again.